Today I will be making GAN generator better. So, as you may recall, or may not, from previous video, I built GAN and generated images were quite bad, to be honest. And I will try to make them better first, and then I will try to optimize the model. Hello, it's me from the future, and first of all I want to apologize about delay. I hope I will post video about optimization this Saturday or Sunday. The reason for the delay is because I overestimate my knowledge of Triton, and as you may see in future, closer to the end, I called writing kernels easy task. And I was sitting there for 8 hours and trying to understand this matrix indexing, and I still have nothing. So sorry for the delay and enjoy the video. I added a try counter. I assume that I will have a lot of tries. So first try, I think I just add normalization, batch normalization, and we will see how it turn out. Okay, this is actually very interesting, because all normalization that I added, it made the model worse than it was. And actually, when I was watching the logs, I noticed that for some time it was going well, but from some point discriminator accuracy fall to 0, and then it accidentally, maybe not accidentally, but jumped to this level. It was jumping back and forth. So I have two theories actually. Maybe this is because of this batch normalization 1 that I placed there, or maybe normalization should be placed after the activation. So I guess I just test two of my theories, starting with this. You know, actually what? I probably add this tensor board or something like this, because it will be way easier to track the loss and accuracy, because now I don't really can. Okay, I have added Trackio and some progress bar, and I already removed this normalization, and I think we can get this model to train. Okay, it is actually not that bad, and I don't really know why AI added this sample per second step and epoch tracking. This is useless, but anyway. So removing normalization definitely helped, but maybe I try to move it after the activation. Actually, wait a second, maybe this will make it even better, because I don't really remember, should I normalize very last layer, I mean output of very last layer. I think we can try this. It doesn't really look better, but we can see there that for some reason accuracy was higher. It means it guesses more times that image is fake. Loss is actually, I don't really know how to analyze this. I guess we can do my initial idea. Maybe I should also reduce the learning rate, because it actually seems to jump very high as fast as possible, and actually loss of generator is also from like almost 0 to so high value. I'm right now very disappointed, because I think it really answers the question of how GAN's unstable. As you can see, really unstable. So I guess we remove the whole normalization and just to train regular model. I don't really know how to make this better. Maybe change the learning rate. I think I try this. Okay, I don't really know how to address this problem, but I have one last weapon, is to increase size of model. But in real life it is not the size, but more like how you use it. So I tried to use number of parameters and tried to use them well, but maybe sometimes size is actually better than use of size that you have. So I'm just going to increase the hidden dim and maybe I will increase the noise dim. Okay guys, maybe size doesn't that matter. I don't really know how to make it better, but actually I have idea. Maybe we will do pre-normalization and, more importantly I think, residual paths or residual connections. I think it may help stabilize it. So I tried. First we do residual paths, then normalization, pre-normalization. Oh wait, I tried to make model deeper. This is actually will be easier to implement, and it may actually help. Okay, bad news for you guys, and for me probably too. Size does matter, at least in models. Result is already pretty good. I think better you can do with deep convolution GANs, which I don't want to do, because I promise that I will optimize. I have no idea how to deal with convolutions in Triton, so maybe this is only the reason why I don't switch to DC GAN. So I anyway try to make training more stable by adding residual paths, but I gotta go. Okay, I'm back. As I said yesterday, I will try to add residual connections. Honestly, I don't see that much of an improvement, but I noticed that it was like more stable than previous run, or maybe not. How to do this? Maybe try to make it even deeper. Oh, okay. I remember that I can try to remove Sigmoid from the discriminator and use binary cross entropy with logits. It may help, actually. I think that making model deeper or bigger is not helping. I will try to search examples from other guys who made this and try to learn from it how they do better images. So first of all, I tried to not go to GitHub but ask AI to point direction for me, and maybe I do something really bad in terms of overall architecture, or I don't know, some approach maybe. Actually, a residual connection should be after activation. Why it has just 2 layers? Again, I can't say it helped or not. So one more last thing I want to do before I go to GitHub is to try add Dropout. does look better, but it can be better. I'm going to search some implementations on GitHub, and if I found one, okay, I have seen some better examples of code, and remember that yesterday normalization was actually worse than the generated images, and this is maybe because of sort of restriction for batch or any sort of normalization in first layer of GAN. So we can't place normalization in first layer. Actually, also almost everybody uses leaky relu with parameter 0.02, and I'm currently use 0.01, so it may be the reason. I saw that they use in optimizer something like beta 1 equals 0.5 and beta 2 is actually the same as it by default. So I will try all those things to implement, and maybe this will work better. Okay, I think it is as close as we can get to really good result. If you know how to get better, please write a comment. I'm very responsive to this type of critique. So now I try to optimize this. Of course, this will be easy because I just will write two kernels, one for block and one for last bit of layers. This is actually easy because I just write one kernel, but I will do this later because I have other things to do. For the conclusion, I can say that I really enjoyed the actual experimenting with the architecture, and I didn't enjoy much stuff about optimization, but frustration is just another step to understand the Triton. So I think I did a pretty good job because previously it was bad and currently it is not that great but better. So if you want to see the code, you can go to my GitHub. All the links are in the description below. Hope you enjoyed the video. Bye.